The electroscope. The following items were used in the preparation of this educational resource: a multi-purpose cleaning cloth, a PVC pipe 1 foot long, 1 inch in diameter, a strip of aluminum foil, an improvised insulator. This is just the top of an orange juice container glued to the other part of a small syringe, a rectangular piece of white paper to create a good background, a piece of bare copper wire. One end is shaped like a spiral, the other end is straight. A ramen noodle box with a small hole in it. An electroscope is a simple instrument used to detect the presence of electric charge on an external object. According to Wikipedia, the first electroscope was invented around 1600 by the British physician William Gilbert. The image below shows a basic aluminum lead electroscope whose parts are the following: conducting disc, insulator, conducting rod, transparent container, aluminum leads. Here is how it works. When a positively charged object is near the conducting disc, the entire conductor, disc plus rod plus leads, becomes polarized, as shown in the figure below. This means that the top part of the electroscope becomes negatively charged and the bottom part positively charged. Since like charges repel each other, and since the aluminum leaves are very flexible, they will move away from each other, indicating the presence of a charged object nearby. If the external object were negatively charged, the electroscope would become polarized in the opposite way, as shown in the figure, but the aluminum leaves would still separate in the same way as before. This means that our basic electroscope can only tell us whether the external object is charged, but it cannot determine whether the object is positively or negatively charged. For comparison purposes, here are the earlier cartoon electroscope and the real electroscope we assembled for this video. Notice that the conducting disc and rod have been replaced by a piece of bare copper wire shaped into a spiral at one end. The spiral is simply an approximation of the conducting disc. We also replaced the transparent container with a box that has a white background to make the aluminum leads easier to see. Let's put it together and see how it performs. Keep this in mind. If the leaves of the electroscope are far apart when no charged object is nearby, it means the electroscope has an excess charge. To discharge it before using, simply touch the conducting disc to drain the excess charge into your body, and then touch a large metallic object or the ground to neutralize yourself. Let's see that in action.